and welcome everyone to OpenCV weekly webinar. I'm Dr. Satya Mallick, CEO of OpenCV. We are joined this week by Niko West and Emil Ernerfeldt, co-founders of Rerun, the new open source tool for logging computer vision and robotics data paired with a visualizer for exploring that data over time. Rerun went live on GitHub last week and has collected over 1,400 stars already. We are very excited to see how it works and what it can do. But first, with me, as always, is Phil Nelson, Director of Content and Creative at OpenCV. Phil produces the show, so if anything goes wrong, it is his fault.
That is absolutely right, Satya. Thank you for that beautiful introduction. It is me once again, the co-host with the co-most, the second banana who is second to none. I am also your plus one and only, and I'll be your Huckleberry. It's Mr. Nelson if you're nasty, but you can call me Phil. And I'm here to remind you of a few things we do every single week here on OpenCV Weekly Webinar, the first of which is a giveaway to you in the audience. Stay tuned for that later in the episode. You will have the chance to answer a trivia question and win a free copy of the new OpenCV course releasing on May 1st about AI art generation and how to master it. We'll also be taking Q&A from you in the audience, so use the little Zoom Q&A button at the bottom of the screen, or ask your question wherever you're watching, YouTube, Twitch, Twitter, Facebook, etc., and we'll do our best to flow that into conversation as time permits. Before we get started today, though, we've got a few announcements here. Satya, you want to talk a little bit about how the Kickstarter campaign is doing for mastering AI art generation?
It is doing awesome. It is doing awesome. We have about 103,000 raised already with the help of almost 1,100 backers. So awesome. Thank you so much who have already backed. And if you are on the fence, now is the time to go check it out. I think no matter what this is going to be a very fun, very exciting course for you. I'm getting hooked to this art generation. That's why I got this laptop also, so that I can try, my experiments were not fast enough. So I got this new laptop with a GPU so that I could do my experiments right on my desk very fast. And it is awesome. It is addictive. It is completely addictive once you start getting into this, because a lot of people love art. They just don't have the skill and the talent to do it. Now it is like, okay, I'm going to use my imagination and not necessarily my skill. I may be lacking in skill, but not in imagination. And so it gives you this avenue to create awesome things. So yeah, very excited about the course.
It's very powerful and fun to just be able to say, computer, show me this. And it's, something completely outlandish. My family had a lot of fun messing with Stable Diffusion over the holidays and in December. And so I'm really excited to see what people do with this new course. And there's just 12 days, I believe, left in the campaign. It's a huge savings off of the regular price, a special campaign price of only $29 versus $59 regular price. So you got 12 days to lock in that huge savings on this very cool course. We've also got, coming up very soon here, OpenCV has once again been selected as a mentor organization for Google Summer of Code. Over the years, we've been lucky enough to participate in Google Summer of Code several times. And Satya, would you like to talk a little bit about some of the cool features that have been brought to OpenCV through this program?
Yeah, a lot of things. Even facial landmark detection was one that I was also involved in. So there are a lot of features that have support, for example, support for RISC-V architecture that was part of Google Summer of Code. So there are a lot of things that have been added to OpenCV as part of Google Summer of Code. And if you're a student, you need to be a student to apply. They have a very good, I don't know, I can't remember off the top of my head, but they pay pretty well. And this is sponsored by Google. So Google actually makes the payment, but OpenCV and other organizations benefit from it. So if you're a student, if you're looking for an internship, now is the time to apply. And we are very happy. There will be a selection process, obviously. There is also a channel or Google Groups where you can go and talk to mentors. Suppose you like one of the projects, you can go and talk to mentors who just to see whether it is a good fit, etc. And so, yeah, please apply. We are very eager to have this internship.
Yeah, and this application process begins on March 20 and goes through April 4. But you can start talking about what you'd like to propose right away. You can go to the discussion page that I posted in the Zoom chat here. I'll also make sure this gets out to the YouTube and LinkedIn videos as well. That's between March 20 and April 4 and we'll let people know what proposals are accepted on May 4th. May the 4th be with you, I guess. I'd also like to give, before we get started, a quick shout out to our friends at Hackster. Thanks, Ginger and Jessica, for your help this week. I appreciate it. Satya?
Yeah, so very excited to have Rerun here. Guys, please take it and show the magic. What's this tool all about? And yeah, it's also open source, so it is doubly heartwarming for me.
Yeah, super excited.
Right, so yeah, we are Rerun, or some of Rerun. So I'm Niko. Just thought I'd do some quick intros on us. So I'm one of the co-founders, CEO of Rerun. My background is basically a computer vision and machine learning engineer. So I've been doing that for the last roughly a decade, mostly different kinds of 3D and mobile stuff. So Emil and I and our third co-founder worked together on a 3D scanning company earlier, and then I spent a lot of time after that doing mobile AR, mobile vision.
Yeah, and I'm Emil. I'm the CTO and yes, one of the co-founders as well. I'm an engineer. I started writing C++ as a teenager, and since then I never looked back there, about to say, but I did switch to Rust about 5 years ago, which is my new favorite thing in the world. I'm going to talk a little bit more about that later, but I have a background in building physics simulation, building games, doing 3D scanning, computer vision, and some cybersecurity work. So I have a mixed background.
And just to give a little more sense of the team building this, so the core kind of engineering team comes from a pretty strong backgrounds in robotics and autonomy, building some of the more famous AR platforms and game engines out there, and also just sort of large-scale modern data system kind of things. Yeah, so just today I thought we'd do a little bit of a quick tour of Rerun first, and then give you a little bit of a backstory and kind of like the problems really we're trying to solve, talk a little bit about the tech, and then hopefully do little live demos, see how much we have time
live
for.
Demo.
Yeah, let's see. Exactly, demo ghost is always a risk. Yeah, so basically Rerun is an SDK for logging computer vision and robotics data, paired with a visualizer for exploring that over time, that you basically log and kind of debug and inspect internal state and data from your pipelines. And you can visualize that either just live right as it's running, or kind of recorded after the fact. You can just kind of, the idea is that you should be able to dump in any data really. Can't handle any data yet, but 3D, 2D, scalars, tensors, text, most of what you might need, just log it in there, and kind of we do our best to visualize it automatically. So yeah, basically you log that, and the first thing you get is just quite powerful inspection of that data. So you can hover, check out things, and kind of understand it over time and over a timeline.
Could you go back to the previous slide? Because a lot of people here are new, they may be just starting out in computer vision. Could you explain what you're looking at? The camera there, they may not, some people may not realize that we are looking at a camera,
Yeah.
There's a lot of possibly mind-blowing shit happening here.
Yeah, there's a lot of things. We can also talk about a little more when we demo, but I can just give you the basic overall. So what's happening here, so this is, you're looking at kind of the output or intermediate output of a 3D reconstruction done by Colmap in this case. And the little frustum that you're seeing there is basically representing a camera and how it's moving through space. And the 3D reconstruction or like SLAM algorithms have kind of figured out how that camera is moving by tracking points in 3D. So that colored point cloud there are those points that have been tracked and then colored by kind of the images. You're seeing a detection that we ran on there too, and started detecting that car. And I guess one of the interesting things that you can see here is that as you're just inspecting this image in 2D, it's kind of shooting out a ray in 3D. So you can see where that would be in 3D as well. And that happens basically automatically when just by setting up kind of the relationship between the camera, how it projects and where it is. We'll get into that a little later in the demos, but yeah.
This is all, you know, every piece of this I would say is so non-trivial that they're individually hard.
Yeah, but we try and make it trivial, so that's the point. But we spend some time doing it, that's for sure.
Yeah.
So yeah, another sort of key aspect here is that basically being able to pull back and scrub back and forth in time like a video editor for all the data that you logged. Yeah, you can use Rerun to build like full dashboards to introspect basically inside your complex pipeline. So here, this is depth guided stable diffusion for you kind of AI art fans out there. So you're just seeing the diffusion process here, and you can do things like just slice back and forth through tensors. So here you're seeing me just like look through the latent representation of this diffusion model. If you don't know what that is, just take the course. Yeah, this whole thing is as Emil alluded to, is built from the ground up in Rust and really focus a lot on speed. So basically, you can just butterly smooth at the 60 FPS, just scroll back and forth through these big point clouds. Rust also gives us the ability to compile everything and run with WebAssembly. So that means that it runs both natively and kind of in the browser as well. And yeah, we just made the beta, or we're calling it beta, public on February 15th. So just quite recently. It's open source under dual license, MIT and Apache 2. If you're a Python or Rust user, you can just pip install or cargo add it today, and we'll be adding like C and C++ support and probably some more languages kind of down the road.
I don't want to get too deep into it here, but I've always been a little bit confused about the dual licensing. I've seen a lot of projects doing MIT and Apache, and could you just super high level, like 2-minute explainer of that?
Emil, maybe you want to jump? Yeah.
Yeah, sure. Short answer is I don't know. Some people prefer MIT, some people prefer Apache. Yeah. And so by providing both, we make everyone happy. That's sort of it. It's like MIT or Apache. It's your choice.
Yeah, it's the user's choice.
And MIT and Apache just happens to be the common combination of almost everything built in Rust, including Rust language itself. So we felt like that sounds good to us.
So, I mean, as far as my understanding is that, you know, both of them are permissible licenses. You have full, you can use it for commercial purpose without paying a dime. OpenCV is also released under the Apache license. We used to be under the BSD license, and the switch was made because it gives some extra protection to, so all it says is that you can use it for commercial purpose, but don't come and sue us, right? If something goes wrong, right? And apparently Apache has slightly more better protection for the creators, so that, you know, we are giving away everything for free, but don't come and sue us, right? That piece is more solid apparently in Apache. But I'm not a lawyer, so I'm just
exactly.
Those were the discussions I was just overhearing when OpenCV changed.
But basically, I mean, to make it, it was just, this is what the community is preferring in within Rust. That's the kind of short answer.
Yeah, we just want to be a good citizen of the Rust ecosystem as well. Like that's one of our.
It makes sense. Thanks for the explainer.
Yep.
Should I move on? Yeah. So I thought I'd just say, so that was, I guess, the quick whirlwind tour there of what it is. There's a lot more depth that we can hopefully get into a little bit, but I thought I'd say a little bit of the background, kind of how we came to this and so on. So all three of the founders, so us two and Moritz, our third co-founder, we all worked together first for a bunch of years at this 3D scanning startup called Volumental. So short story of Rerun is basically that I was there working as a ML vision developer, and then Emil showed up and kind of revolutionized how we did things. So he came from the gaming industry and just showed up and built some really amazing visualization tools. And in the beginning, that was just visualization tools for our data and kind of the debugging for the tech team. And that ended up kind of spreading through the company and being a really, really important tool for for why that company became quite successful. And so after leaving, I just missed that tool a lot, and I've been building like horrible versions of it over and over again for each new project. And at some point I just got fed up, and it's time for everybody to have a much like basically an upgrade to the tools that are available. So that's kind of the backstory, I guess.
That's great. It follows the three virtues: laziness, impatience, and hubris.
There is. That sums it up.
I believe I think Larry Wall, the legendary Perl programmer, is where I first heard this. But you know, the three virtues of the software engineer: the laziness, meaning you don't want to keep redoing stuff; impatience, meaning you want to optimize it and automate it; and hubris, thinking you can.
There's another version of that. As engineers, we don't do things because they're easy. We do them because we thought they were going to be easy.
Exactly.
Unfortunately, it's a little bit too close to home, but
yeah.
Actually, it's the same with startup, that startup founders start companies so that they can work from 5 to 9 or something instead of 9 to 5. Work 16 hours a day so that they don't have to do the 9 to 5.
Yeah. Again.
Too close though.
Too close to
home. So I thought maybe I'd actually go ahead and make, hopefully at least, the whole thing a little bit more concrete by talking through the kind of our experience at Volumental and kind of the grounding in that. So Volumental does 3D foot scanning in like physical retail to recommend shoes. So that in this case we built this hardware and all that stuff, and so just summary here, you can kind of see there are 4 3D and color, or sort of 3D and depth cameras here, and take input or take the data from that, do a bunch of magic, and kind of out a really awesome working product. And that under the hood, sort of, if you lift up that's quite before it sort of became a working system, it ended up being quite complex. So not so important exactly what the steps are here. This is really actually a huge simplification of the system as it was when I left. But yeah, you have to do data captures. You can do a lot of ways on the fly, like calibrate all those sensors, validate the input data, 2D, 3D segmentation, 3D reconstruction, 3D shape alignment, measuring, and kind of extracting features from the feet, and then doing recommendation. And some of those parts were learned with machine learning, some more classic vision and optimization. And really, like, on any given day as a engineer, you could be diagnosing an issue or kind of improving performance anywhere in this pipeline, or holistically across the whole thing. So it gets quite complicated.
And that's actually, so that hits home to me because I wear inserts in my shoes because I have flat arches. So, and it's medical. I mean, it's something every day. So it's not just like Stable Diffusion, a lot of these tools and they're kind of toys. This is real physical stuff that you're putting in, somebody's putting their feet on this all day. And so you really, really have to get it right.
Yeah, all day, and around the world. And I think when I left, we were in 40 countries, and so just live everywhere. And you can imagine, like in the real world, like everything goes wrong, and our product needs to deal with it. And that does get complicated, and tooling is basically the only way to kind of scale that.
When I started my first company, and I had that was also my first job. So somebody advised me that you should, when I got my first paycheck, right? Somebody advised me that you should invest in 2 things. One is a very comfortable mattress, because you're going to spend 8 hours in that mattress, and then very comfortable shoes, because you're going to spend 16 hours in those shoes. So that's something.
Yeah, and anything that goes between you and the ground is the old advice. Spend on socks, pillows, bedding, shoes.
Right.
Nice. I love it. So I guess the other side of this is that, okay, we had this complex pipeline, and now, but all that code actually needs to run on a lot of environments. So as you're developing, maybe you want to prototype in notebooks or Python scripts. probably your production code is running in C++. You have batch evaluation jobs. You have kind of running like experimentation live on your developer workstations, test devices, production devices, maybe manufacturing testing. Just a lot of different environments, basically, which makes things harder. So some of those environments, there's no screen. In some, the data volumes are very large. In some, it's very important with fast iteration. In some, security is more important, and other convenience. So just kind of a complex setup where kind of everything needs to run. And when you're building computer vision, basically, particularly for the real world, I guess, like real products, like visualization is absolutely crucial. Like, you wouldn't just build a model, then kind of look at your map score and think, oh, it's good, and then just ship it blindly. For the very least, you need to visualize just to verify that it's doing what you think, but you'll also be using it for debugging and kind of just building intuition for your next great idea, and not least communicating with within the team what the problem is, but also a lot externally or with kind of other stakeholders in the company. So just completely central, and having great tooling for this kind of stuff can just have a huge impact on productivity. So I'll walk through a couple steps of trying to build some visualization. So I think what I've done 100 times, and like where most people try to start, is just really simple, just inline visualization. So that tends to mean something like you just start sprinkling code with like, oh, if visualization is turned on, show it, like call imshow or draw geometries, or kind of just sprinkle with like inside your algorithms, just pop up a visualization window and look at it. You'll tend to combine that with like a couple of maybe scripts or specialized app just to look at some aspect or look at some data. And that's the awesome thing about this kind of setup, is that you just get started. There's basically no friction, at least when you're starting. But then kind of a lot of downsides start coming when you do this more and more, and your system gets more complex. So you kind of get this trade-off that you can't escape, but like it's very hard to keep your like algorithm and systems code clean and at the same time also having a lot of visualization. Like your algorithms and visualization become completely coupled, so that just makes it really hard to work with the system. You end up re-implementing the visualization on a bunch of different places, and it never really matches. You can only do it if you have a screen, so you can't really visualize what's happening on an embedded device or on a server. And you can only go forward in time completely synced with the program that is doing the algorithm calculations. So if your visualization, you cannot basically go backwards. There's no state. So you get quite a weak visualization system, but it is easy. So next step for most teams is trying to centralize everything basically and formalize it a bit. So usually get together and kind of decide what are the most important data types, design a schema for that, something like protobuf or flat buffer or something like that, so that we can just consistently serialize and deserialize that data from anywhere in your program. And then you'll go together, maybe start a different developer, different team to build like a centralized visualization app that kind of everybody can use. So that's really great usually. So directly you have like decoupling of the algorithms and visualization, much less duplication ideally. It supports a lot more environments because all you need to be able to do is just dump out this data. But you do have this, it is a big upfront investment. You don't have this from day one. If you want a good system like this, you need to spend a bunch of effort on that. You lose directly this live aspect of being able to look at what's happening right as it's happening. That's fixable with more engineering, but it's a much bigger project if you're not going to support a live streaming as well. The biggest problem is probably that there's a lot of friction for the developer. So if you're going to add one new visualization and that didn't exactly match the data schema that you had, like you needed to add a little more data, that's now a much bigger project. So you just end up not doing it. Or if you as a algorithm developer, you want to change the visualization because you want to see some different aspect of the data, probably you don't know how to change that app basically, because it's done on maybe done in a different language that you don't know, or a framework. It's kind of external from what you know. So what ends up always happening is that developers go back and have their own personal visualization system. So you basically reintroduce all that duplication again. So we could keep doing these steps, and people do, but the kind of our experience with this is landed us with this list of goals for visualization. And so one of them is decouple visualization from other code, just really minimize the friction, particularly for the algorithm developer. It should work both live and offline. You need to be able to dump or get data out of sort of many multiple processes, have that synced, multiple languages, multiple environments. Basically, it needs to be super fast and beautiful. It's actually a really important part, because you do want to communicate with external stakeholders that are usually configurable and extendable, because we can't possibly predict what the algorithm developer is going to need. And then sharing, collaboration, and kind of you need to have also a consistent view, and they want to be able to use the same thing basically from like the first earliest prototyping like all the way to production. So yeah, basically that's what we're trying to work towards and achieve here at Rerun.
Okay, I'm gonna talk a little bit about how things work technically before we jump into demos, which I think everyone is waiting for. So what we have is two logging SDKs, one in Python and one in Rust, and more coming. I'm gonna add C and C++ next. And what you do is you log things like point clouds, pinhole cameras, images, just like you would log text. But instead of just being printed out the screen, it's sent to our viewer. So you can, from the SDK, just start our viewer, or you can start it externally as an external app. And then the login data is streamed over a network, over the WebSockets protocol. And this allows you to see a live view of your program as it's running. You can side by side, you can have your Python code running, and then you can see live what is being output as it's being outputted. At the same time, you can also scroll back in time and see, go back what happened there. You can also save to disk, to an RRD file, we call it, rerun data, which is very useful if you want to share it with a colleague, or maybe you have a long running process, have a big batch job and you just want to save all that visualization data to a file and then look at it later. So we build this very flexible system, and because it's also a very WebSockets, you can run your visualization, your code on one machine and look at it on a completely different machine. So you can run your logging data on the cloud, for instance, but look at it locally. And we use WebSockets so that we can run the viewer in the browser, which I'll get to in the next slide. So as Niko mentioned already, we've written everything in Rust. So for those who don't know, Rust is like the new programming language on the block. Rust 1.0 came out in 2015, so it's pretty new. It's
really
like
taken a bite out of my beloved Python lately.
Yeah, I think it is pretty interesting, taking a bite of Python, but also out of C and C++.
Yeah.
Very high performance. I mean,
I think much more from C++, because C++ developers love Rust now.
Yeah.
Because they mostly hate writing C++.
Right.
Exactly.
That's
Yes.
Python, for all its failings, it still is very easy to learn and write, especially for small projects or medium-sized projects also.
It's very human understandable. I find Python to be a very beautiful language to read.
Rust is the most loved programming language on Stack Overflow survey for the last 5 years, I think.
Wow.
And it's for good reasons. Like it's the first real contender to C and C++, I would say. Like it's a system programming language, but it's safe, which is a first. Like it's pretty remarkable achievement. So we use it because we love it. Like it makes us more productive compared to C or C++. We use it because it produces very performant code, and we use it because we can run it on any machine, including inside a web browser. Which is very important for us.
Solid,
Rust is also very easy to interface with other languages, or at least languages that already have a C FFI, like Python does. So we use a library called Py03, which is gives us easy bindings between Rust and Python. Very, very straightforward. We we use Apache Arrow, which is like a industry standard for data formatting, like how you put data in memory or on disk for a portable way. So when we send the data from your application to the viewer, we use it via the Apache Arrow format, and that's also going to store it on disk. And this will also make it easier to add more integrations, either by us or by like our community, to extend basically the capabilities of Rerun. So extensibility and like being able to extend and augment Rerun is also one of our big goals here. It's not just a black box. We want to invite people to make it better. For rendering, we use WGPU. So this is based on the web GPU. This is a new standard for doing graphics on the web. But WGPU is a library that kind of has a similar interface to web GPU, but abstracts over all platforms. So it runs on Metal on Mac, it runs on Vulkan, it runs on DirectX and so on. It's just a very nice and performant library, again, for portability. Mm-hmm. And I've touched on WebAssembly already. Most of you probably know what that is, but it's a new way to run, basically compile code that is usually only run natively and then compile it for the web. So this is a very interesting new development in the world. I'd say one of the most exciting things of the last 5 years, I would say, WebAssembly, because you've seen a lot of apps that are web first. If you take your Slack or your Discord or something, it's built in React or something like that, and it JavaScript, the TypeScript, and it runs in the browser. And then when you download the Slack app, you're also downloading basically a browser for Slack to run in, usually Electron. And the result is usually something that starts pretty slow and it's a bit sluggish because browsers aren't really built for being high performance. For something like Slack or Discord, it doesn't really matter. But for something like we're doing, high interactability, it's a no-starter. So instead, using WebAssembly, we can actually target desktop first and then move it to the browser, which is pretty incredible. So we can get almost desktop speeds in the web browser. But yeah, we
also
can't use
in a lot of projects where we have to deliver like an AI model through the web browser. WebAssembly or a library built on top of WebAssembly is used quite frequently.
Yeah, it's finally like I can write something else than JavaScript and have it run in a browser, because that's a long time coming. I'm not a big fan of JavaScript. Anyway.
Are there any? I'm not sure.
I'll shut up because I'm gonna make people angry if I start talking about JavaScript. Anyway, for the graphical user interface, we use eGUI, which is my own library actually for doing graphical user interfaces in Rust. And it's this immediate mode graphic interface, which comes from the gaming world, which brings us to our next slide. So a lot of our design of Rerun is inspired by the gaming world. So me and some other of my colleagues come from the gaming world, and we have a little bit different outlook on how to build apps. Basically, a game is an application where performance and interactivity is paramount. Like that's what you want. You always want to hit that solid 60 FPS or whatever, and have everything be fluid and nice. Otherwise, your users will not like you. And we think that should be applied to any application, including Rerun or Visualizer. It should be fast and fluid, not stutter, and be beautiful. So we're trying to get that. So to get that, we have trying to design the application basically similar to a game engine. And one of the things from gaming world we brought in is the immediate mode GUI. And this is too big of a topic to bring it out here, but it's basically a new way to write GUIs that it cuts out a lot of, you don't have callbacks, you don't have message passing. It just simplifies the way you write the GUI. And it's well adapted for highly interactive applications where a lot of things are changing on the screen at the same time, as opposed to like a static application where it's mostly text and sometimes you switch to another thing and so on. Another thing we brought from gaming world is the entity component system, which is more and more popular in modern game engines. And this is basically a way to make things more composable. So for instance, instead of having a point as a specific object type and then have, let's say, images as a specific object type, instead we have, you can have the position component and add the radius component to that, and maybe add a color component on that, and yeah, then we'll show it as a point in the world. We can also add the label component onto it. That means we'll show a little text next to it. You can add the label component onto anything, and it becomes very orthogonal and composable. So this is part of our strategy to make Rerun composable and easy to extend with your own data types and components. So yeah, that was like the whirlwind whirlwind tour of our tech stack, I think. How about we jump onto some demos?
Demos.
The demo time. All right.
Yeah.
Cool, thanks.
Hell yes to that.
Okay, yeah, see a little hidden code there. Let's see if we can make this run. So first thing I thought I'd do here is just look at that reconstruction there from Colmap, or a similar example. It's not exactly that, but basically that. And so what we're going to see here is we're going to run a script that is going to sort of unpack that data from the basic Colmap output and sort of start logging it to Rerun. So see Rerun pop up directly, and then here it's kind of streaming in that data live. So this doesn't look exactly like what we saw before. So let's see if we can get it to look a little closer. So, but starting out, I just thought we'd orient ourselves a little bit. So in the bottom here, we have kind of the streams view. So here we can see the hierarchy of the data hierarchy. So let's see, it's a little bit of a deep topic, but you basically log data to sort of hierarchical entity paths, we call them. But so, for instance, let's see, we can just scroll down to get to something reasonable. So yeah, we have the images here. Image tensor was logged to the path camera, image, camera and image. Right? There you can have them. And then we also have these key points, which are these things that we see in here. And so all the data has some path like that, and that's up to the user to build it up themselves. And here we can kind of see all this data as it's coming in over time. And yeah, we can scroll back and forth in time, and that syncs across all these views here.
That's pretty smooth. All the not only there's the point cloud that you're rendering, right, and then all the images that you're displaying, etc., and that's pretty smooth, right?
Yeah, this hitting that 60 FPS benchmark.
It's hitting way, or I think this should be a lot better than 60 because there's actually not that much data in here right now. But some of the cool things to note, yeah, right, as we have this thing where I can inspect kind of some pixels here, and I kind of get that ray shooting out. This is actually the full view, so it's not just like only the image that we put out in 3D. You can kind of put anything in here, and this it's basically the exact same view that we're rendering inside of 3D, and that's one of the benefits of writing our own render from scratch, so we can do that kind of stuff. Another kind of key concept here, I guess, to get in is the time. So you can log data to automatically all data you log, it gets assigned the log time. So that's kind of the time that when it was logged. That's obviously useful, but sometimes you have other concepts of time that could be optimization step, or maybe it's the sensor input time, or kind of that's the user's choice. But the data, you can log it out of order and from multiple processes and kind of get it in. And yeah, we organize your data according to all those timelines, and you can kind of choose and play it and that kind of loop and things like that. Because that's kind of that bottom. I thought, yeah, I just show a little bit of customization. We can't get too far, it'll take too much time. But one of the first things here I don't like is that this camera frustum is like in the way of the points, which is really annoying. So I'm going to just go select the image space, which is where I had logged the camera, and just pull in that the image plane distance. That's just the kind of parameter here. And this can also be useful to sort of, sometimes you might want to swipe this in and out of to
Right.
kind of see where things end up. But I kind of like this better. It makes it easier to see. So that I kind of I like this better. I think that these key points here are a bit annoying in 3D. It can be useful to see them in 2D, but I'm just going to drop them out. And then this is part of a 3D reconstruction. So I would actually like to see all the points. So I'm going to go ahead and do that. So I'm just going to increase the history. So now I have all the points kind of accumulating.
Seeing the car there.
Nah. So yeah, exactly. You can kind of start seeing the car, but yeah, you can kind of start seeing it, I guess. So that's just one of the things that I think the points are a little small. So I think I want to express the points in UI points. Oh, 2 is way too big. I tend to like maybe something like 0.8 is nice. Yeah, so I think that's a little bit better, a little bit more closer to what I wanted. And yeah, so basically that's kind of how this works. You can, I don't know why you'd want to do this, but you can, you know, move these around. Let's see, my little zoom thing is in the way here, but I move the zoom. There we go. Yeah, just kind of drag these around and kind of set them the way you like them. Yeah, so that kind of
reminds me a bit of the OBS open broadcasting software that I use. Is very similar.
Oh, nice. Let's see. So yeah, I guess one more key concept maybe to get into is these transforms, like how we set this up. Maybe the easiest thing is to look at the code that kind of built all this.
Yeah.
So there's this simple script. Most of the script is just like dealing with some particularities of the call map format. But basically what it's doing here is that it's iterating through the images. This is about reading reading the data out. And this code right here is basically all you need for a rerun. So here was that call I told, like how you set the time. So here we're just like basically setting, okay, for all the data that comes after this, associated with frame and whatever the index comes from the loop here. Then we're just logging this scalar, which is just the average point errors. And that is what's generating this graph here. After that, we log the 3D points because from CallMap, they just showed up in 3D space. So yeah, we just log them here with the colors. And these are just NumPy arrays. So this is a NumPy array with, you know, XYZ, XYZ. And this is a NumPy array with RGB, basically. You can see them being created here. In this case, it wasn't a NumPy array. It's just a list of points, but it doesn't matter. You can fill in list of points, NumPy arrays, kind of PyTorch, tensors, kind of just sort of whatever. And here we're kind of showing one key part here, which is a little bit getting at the flexibility that we get from this entity component system. So this is just kind of the beginning of this flexibility, but right now you can do things like this. You can add just an extension. So here I wanted to see on each point, I want to see, yeah, well, what's the error during the optimization for that point? So I just kind of added that in here, and I can just kind of select into these points here, and I can see the error for each point just by kind of hovering around it. Nice. So that kind of, yeah, you can add on arbitrary things like other full arrays of things, or the sort of whatever you need. All right, so the next interesting thing here is basically us setting up the camera transform. So here we log the camera, and that basically is just logging the position and like rotation and the translation of the camera where it is. And it goes like this. Yeah. Next in the hierarchy, so that sets up where the camera is, and now comes the kind of transform between camera and image. So we're here logging the pinhole camera model. So if you know any 3D geometry, it's like sort of a basic concept. If not, there are lots of good OpenCV tutorials. But that we're kind of logging one step lower in the hierarchy, and then we can log data to that point, to the image. So here we're logging the image. You can log it as a file, kind of a blob of sort of encoded data, or you could actually just send it in as a array. And then also adding on these key points on here as well. And just logging and setting up the hierarchy like that basically builds this whole UI. Should I take any questions here, or then maybe jump on to the next thing?
Super powerful. Wow. Yeah, so we got about 15 minutes left. We'll pause here and do our giveaways for folks that have a hard stop, just in case. If you're just joining us for the first time, or you need a little reminder, one of the things we do every single week on OpenCV Weekly is give away something to you in the audience. Here in the Zoom chat, folks will have the opportunity to win a free copy of Mastering AI Art Generation, the upcoming course from OpenCV, which is currently on Kickstarter. If you don't win, you can go back it on Kickstarter.com for just $29. The regular price will be $59, so lock in that savings quick. If you have won recently in the last 2 months, please don't answer and give other people a chance to answer. You'll be answering the question just in the regular Zoom chat here on the show. During the presentation earlier, Niko talked a little bit about their previous work doing 3D capture. What was the name of that company? Wow, Jagadish just
Fast.
right off the box. Holy moly. Get out of my head, dude. The answer.
I know. Why, Phil and I are laughing right now. Look at the second person who answered.
Yeah. Holy moly. There's 1, 2, 3, 4 of them with a timestamp of 12:48. I'm going to have to go down to the milliseconds to see who won this one. I believe it is Jagadish. Yes.
Jagadish shows up on my screen first. Divya is second.
Yep.
Same.
And then
it's funny because Divya was second last time also.
I know, just something with the internet cables, just move closer to where I am, maybe. Yeah, Jagadish, congratulations. Please send one email to phil@opencv.org, and I'll make sure that you get that course when it launches on May 1st. For the rest of you who didn't win, go to kickstarter.com or opencv.org/Kickstarter, and you'll be able to check out that course and lock in your savings off of the standard price. Yeah, back to what else you got for us, Niko and Emil?
Jagdish expected that
Awesome. I love when you win on internet speed and typing.
I think that's funny.
They're hacking my brain is what's going on here. They're getting way too familiar with my thought processes. I got to shake it up next time.
Nice. Let's see. I thought maybe I just show as I said, you can open these files. So I had maybe not as well laid out thing, but here this is inside of a stable diffusion run. So here again, you kind of get this you can kind of look at the data in these different along these different steps. And these stable diffusion things, I made this by I pulled home
we might use it in our course just to show off, how this thing is
built it up.
Yeah. So I did this just by pulling home the Hugging Face stable diffusion implementation. So this is the depth guided stable diffusion. I just kind of went through it, and where I didn't really know what things were exactly. I just added some log lines, and that kind of built this thing up. You can make a simpler one just by kind of hooking up Rerun to the just callbacks, the basic the built-in Hugging Face callbacks, and you get some a little bit simpler, but it's a good start. Yeah. So I mean, maybe I could just say something about what you can see here. So this is the input image. It calculates or kind of uses a neural net to calculate the depth. It's actually not the real depth, which you can kind of see here if you look. So because you can inspect, you're seeing the kind of the depth, or what's supposed to be the depth there is super large here for the head, and then small for these things that are far away. So, or smaller, it's still large. So it's actually, these neural nets, they don't actually use real depth. They use something called relative inverse depth. So that's something you can go check out when you check those networks. But that's something I also discovered when I looked at this. I was like, whoa, that's not depth. Here in the middle, we have, these are the prompts that I tried out here. You can go check out my poor prompt engineering if you want. and here, yeah, here's the final output in this case. So just some things that you can just check out here. So here are the text embedding tensor, and like one thing that becomes very obvious is that I could have, there's space for a lot more tokens. Just again here, so it's using way less information, sort of controlling information than it could. Just one interesting thing here. So there are a lot of internal tensors that are interesting to look at, but I removed most of it just to make this relatively simple. But if you know anything about stable diffusion, it basically takes an input image, it encodes it as a latent variable. So we can actually go check how the original encoding, maybe we step it one step forward. Oh, let's step actually instead. There we go. Yeah, so it takes that and encodes it in a tensor, and then it adds some random noise. And then it basically, this iterative process where it kind of does diffusion. So here you can see how this particular one works. So this is all of these are kind of the same in the latent representation and the input, but it tacks on this last tensor in the end, and that's the kind of depth tensor. So this is how the input differs from the latent representation. And then there uses a decoding network to go from this tensor, the latent tensor that you see here, up to this image. So that's something that I basically learned about by kind of doing adding some logs to this implementation. So I think that's kind of one interesting thing.
That's really nice. Yeah, I mean, people will learn a lot because what's going on inside these black boxes, it's not easy to understand. And you have to do this kind of logging to go and check what's going on, right?
Yeah, exactly. I think, in the beginning, like early days of deep learning, people were saying like all of these systems are just going to be one network, end to end, you solve everything. And I think we're seeing now again that for these big systems, it's actually useful with some modularity and repeatability. And we're seeing them people starting to build the really interesting applications by piecing together more general networks that can be used for different things, and then kind of maybe training it a little bit so whole sometimes. And this becomes useful to kind of pick it apart and kind of really see how the whole system works. Let's see, I'm just gonna close down that one. I thought maybe I would try this one just because it makes it clear some useful things a little bit more that you can do with tensors. So this is
already cool.
Yeah, this is, I mean, fun. I mean, it's medical imaging is cool, right? So it's always fun to look at. So this is a MRI scan from a that we're just sort of slicing through here, also nice and smooth. And here you can do things. So yeah, you can change kind of a little bit how those colors are mapped, set different kind of color scales if you want to kind of look like that. I actually like it to be around 1. But I think the most useful thing, and this works for any, like this thing happens to be 3-dimensional because it's like an MRI volume, but you can work for any amount of dimensions. You can just sort of swap around the dimensions and slice through a different direction. Maybe actually I want to have it flipped. Now it's upside down. That's actually kind of weird. We put it like, okay, what's better like this? Here we go. This from the side, and just sort of slice through like that. And that can be really useful, particularly for these like larger, sort of higher dimensional tensors to kind of understand what's going on. So I think that's sort of one interesting one to check out. We could do maybe this one as well. So this is using MediaPipe, another sort of good kind of live application to do that does like human pose tracking and some segmentation. So here it's also, this one is fun to slice back and forth. There's some value in that on its own. But I thought, I just show some stuff here. So we have this segmentation mask, and you can kind of look at them and kind of inspect how that's going. For instance,
you can
see
the labels there as you hover as well, which is nice.
Yeah, exactly. So this one, it particularly doesn't handle when it's spinning fast enough here, and that's kind of an interesting thing to maybe debug a bit. So it's missing the feet here, and there's a lot of blur.
Yeah, motion
Yeah,
blur.
the motion blur seems to be that, and you can kind of maybe guess a little bit how it's doing. Like this is doing smooth tracking, and you can look at maybe how it's maybe not handling rotation correctly. Just my guess when I just kind of look at this.
Yeah, the
And
other thing to keep in mind is, when, let's say you're visualizing these things on just a single image, it's very easy to miss some of these details. Like you would look at the body, oh, this looks, everything is looking fine. But if you look at it on a video, then all these mistakes pop up very easily. And that's, one trick to use.
Yeah, particularly, and in a video, and another thing about stopping the video, because when you're playing it, I can set it on loop mode. And the first time I looked at it, I was like, oh, it's perfect.
Yeah.
And I completely missed that I mean, you actually have to stop and go look, oh, here, it's actually not handling this well. And this one,
small number of frames to have to inspect, yeah.
Yeah, and this one, it's connected to, it does a 3D estimation, so we get these things out in 3D as well. Yeah, we can
also
hide them.
Missing a mask there for one frame. If you look at streams here, I've never noticed that before. There's one frame there.
Exactly. So that's just, this ends up being a really good debug thing. Apparently, the mask extraction just failed for this case. So this, just seeing the timeline like this tends to be a good visual thing. We can just check out the log. I don't know if it's interesting for this one. Yeah, the log times are pretty smooth here, so it looks like everything is pretty normal. And you can kind of look at this one actually has sort of video time, so this will make it look a little more realistic. So maybe on this one, maybe something we can do is like, I think it looks a little weird that the background has the mask instead of the person. So maybe we just kind of go change that.
Just a small interruption, sorry. So I have a hard stop, unfortunately, in 1 minute, but I would like you guys to continue. Phil can keep running the show because this is very interesting, fascinating stuff. Unfortunately, I have to leave in 1 minute, but I want you to continue because many viewers might have questions. And this is such interesting stuff that I don't want to stop the show. So I'll take a leave. Thank you so much, guys. And Phil, please continue with the show. Thank you. This is very interesting.
Cool.
Okay. Thank you all.
Nice. Really nice to see you.
See you later.
Okay. So actually, maybe, oh man, I already killed it. I can show you again. But basically, how we were coloring and kind of setting up labels for the things you were seeing there is that you can add this thing to the hierarchy that this like entity path hierarchy that I told you about. It's called annotation context. So in this case, we set up 2 annotation contexts. I set up one for the mask here because the mask has it behaves a little bit differently than the points. That's just how the output looks from MediaPipe. And so this is basically how you set up that whole all those points. So you basically give it a list of these key points, sort of what index has what label and so on. I can take a look at that after. And this is the kind of label map or label tree for the mask. And I kind of thought it looked a little bad like that. So I'm actually going to move this color over to the background instead. And then I don't know, what color should we add to the
That's a nice
to the guy?
Maybe
bluish green.
Or maybe like some kind of a violet.
Can anyone give me a little RGB code for
200
violet?
0 100? So it'd be very good.
Yeah, that'll be.
All right, nice. Okay, there we go. And so then let's run that again. Yeah, that's a nice old.
Maybe not violet, perhaps.
Not quite violet, but
I like it.
We have a question
it's like a little disco style.
In the chat here about if we can just show the segmentation mask and hide the RGB. Good to visualize that these are also just 2 images overlaid on top.
Yeah.
Sometimes you just want to watch this, and sometimes you just want to watch the RGB without the segmentation mask, so you actually can see the blur. Right.
Wow. Yeah, just insanely powerful here. I mean, this is so, yeah, this is tremendous.
You can also show them side by side. Like maybe you can show that quickly.
Oh yeah.
Set up a new view where you have the
I
segmentation.
can add a new video thing here. Maybe we drop the hide the 3D stuff. It's probably a good idea. I don't have enough screen real estate here, but maybe is it better on top of each other? I'll put it to the side. Maybe that's better. No. Okay. Is it like this?
Need a wider screen.
Yeah, I need a wider screen.
A mask on the video there, so
yeah, and maybe drop the point too.
It's very easy to like customize and set up what you want to watch.
Yeah. Yeah, so that's kind of the idea.
Very, very cool. Like this is I can pretty much everybody I talk to about this stuff every day will probably end up using this for something. So impressive what you all have built here.
Awesome. Yeah, I hope so.
Thank you.
So yeah, are we ready to take some questions maybe?
Yeah, let's do some questions. I think I could go on forever, so.
Yeah. We'll have to have you back after, maybe 6 months or so of building. We'll see what other insanely great stuff you've got. You can go ahead and unshare your screen here, and we'll do a few questions from the audience here. So over on LinkedIn, we had somebody asking, actually, sorry, this was on YouTube. We had somebody asking about ROS, the robotic operating system, and ROS bags specifically. Are there any plans or any way to bring ROS into Rerun here?
Sure. So we have some like examples coming out with ROS soon. I don't want to promise unfinished code yet, but there'll be some examples coming out. At the first step now, it's just basically about re-logging the data. So if you have a ROS bag, the easiest way is to just use ROS.py, read up the data and kind of log it to Rerun. Hopefully that example that we put out will help you see it doesn't map exactly to the ROS model of topics.
A little bit of data massaging has to happen in between is what you're saying.
Not so much the data, as more as the kind of hierarchy of transforms and topics. There are some subtleties, or not, it's not so subtle, but there's some differences, and hopefully that example can help with that. And yeah, you could also set up a ROS node, of course, and just kind of use that and listen with that. So that's, I think the example will be a ROS node running, what is it, Turtlebot or one of the simulators.
You say like one of our employees is the designer, like one of the designers of original formats.
Yeah, so Jeremy
right now.
Yeah, Jeremy on our team he worked on the ROS bag format. So that's kind of what's going to be there back at Willow Garage. So that's what's going to be there basically, yeah, next week or something like that, a week or two. But we will also in time build like more deeper integrations to make it kind of work more natively. But basically that kind of native support, yeah, basically it's a little bit further out, but it's coming.
Yeah, that makes sense. And so obviously this Rerun here is a really impressive part of many different workflows and tool chains I can envision. Somebody asked in the Zoom chat here, do you have any recommendations for, or any just kind of impressions on what do you think are some of the best data management tools for AI and CV data like this, if you're working in the cloud, for example?
Oh,
like
yeah,
we've got our friends at RoboFlow. There's a few others. Like, do you have any sort of personal feelings about like the ones that you go back to or like to use?
I can't say that I do. It also depends on what layer of the kind of what data are we talking, training data or like so I don't know that I have a favorite really.
Whoever gives you the most free credits.
Something like that. I've been a Google Cloud user a lot myself. For a while it was really horrible to use like PyTorch with sort of more embedded things and mobile, so I've done a lot of TensorFlow, that means TF records and kind of that whole thing. But I've honestly built a lot of the rest of the stuff myself or with those teams on outside of that.
Yeah, that makes sense. We got another one here asking about why PyTorch and not, or why TensorFlow and not PyTorch.
Before, yeah, it just used to be harder to get things to run on edge devices. I don't know that that's the case anymore. I prefer PyTorch as for building algorithms, and I think find it a lot more natural and easy to use.
Could be a question about the example we just showed as well. I want to clarify in case there's some misunderstanding here.
That was what it was in reference to. Yes.
Like these are only examples. Rerun compatible with basically with any tensor you throw at it, whatever system you have. As long as you can create an ND array of it where it's compatible with Rerun.
Yeah. So for instance, this stable diffusion one is PyTorch. This is MediaPipe. It runs, I think, under the hood. That is TensorFlow Lite. Yeah, we don't prefer anything particular.
Don't discriminate.
Yeah, you play agnostic in the choices there. We got so it looks like somebody in YouTube showed up late. Username Defense asks, "What is this software for?"
Great.
Give us your like 2 or 3 sentence pitch. I'll splice this into the beginning of the video for us.
Okay, I know. Yeah, it's the software is for understanding computer vision and robotics applications, and it's doing that by visualizing the internal data and the input and output data from whatever those systems are, and you do that by logging the data out of your systems.
And if you arrive late, we are Rerun at Rerun.
Yeah, that's true. Yeah, and you can check it out more than
Rerun.io is our webpage. So yeah, easily visualize. Sorry.
No, take it away.
Just what Niko said. Just easily visualize data, any visual data you want. So that's our goal, to make your life easier, so you can spend more time on algorithms and less time battling visualizations.
Yeah, and from what we've seen so far, I think you've done a great job already, and I really can't wait to see what you all managed to pull off in the near and far future. It's a very impressive piece of technology you've built, and I'm looking forward to messing with it a little bit as well. I've got some irons in the fire of my own, and so I think I can imagine using Rerun for quite a few things already. Before we take off here today, thanks so much for joining us, Niko and Emil. Next week, our guests will be talking a little bit more about the Intel Dev Cloud for the Edge. We had another great presentation from them a few weeks ago that I feel like they bring a lot of value to the show, and always happy to see Intel folks that Dev Cloud is free. You can just use it to test your stuff on Intel hardware without paying them anything, and I think that's also another really powerful tool for small developers, small companies like Rerun, like OpenCV. Not a huge organization, just a huge library. So please join us again next week. You can find us the same bat time, same bat channel, 9 a.m. Pacific, Thursday morning. Thank you so much for joining us. Take care of yourselves out there. Take care of somebody else if you can, and we will see you next time.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. This week's episode was brought to you by OpenCV Courses. Learn computer vision and AI from the best at opencv.org/courses. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.